Okay, so now what we are going to do is we are going to classify our differential equation. One of the most important concepts is that how to classify a differential equation based on order. So order is a very simple idea. So in a differential equation, I said you involve derivatives. Order means the number of highest derivative that appears in the differential equation. So you can have first derivative in your differential equation, second derivative in your differential equation, third derivative, as many as derivatives you like, but what is the highest derivative that you have in the equation? Okay, so let's look at some examples. All right, so here you have y and you have first derivative of y with respect to x. So you have taken the derivatives up to first derivative, right? So the order in this differential equation is 1. Versus in the second differential equation, so you have no derivatives here. Here first derivative, here second derivative. So that's the maximum derivative you have taken. So this is a second order differential equation. All right. So I'm going to get into some tricky stuff here. Okay. So be with me. Here the first derivative, here the second derivative, here you have taken the fourth derivative, right? So the maximum derivative you have taken here is 4. So the order of this differential equation is 4. All right. Now let's get into an interesting example. All right. So here first derivative. Okay. But here what is the derivative that you have taken in this term? Is it 2? Or is it 3? Is it 2 times 3, 6? Or is it 2 plus 3, 5? What's the derivative? Now, there's a difference between the number of derivatives you have taken and the degree. Now, what is degree means? Okay, y is equal to x square plus 7x. What is the degree of this? Let's say this is a polynomial. What is the degree of this polynomial? 2. Right? So what is the meaning of this 2? That's a power. You multiply x by itself, or 2 to the power 3. What do you say that? 2 times 2 times 2, right? So that's you have multiplied 2 by itself 3 times. So this we call the degree, the power. But here, when you talk about derivatives, when you use the Leibniz notation, for example, d square y dx square. So this is actually not the power. It's telling you that you have differentiated y with respect to x 2 times. Okay, it's not a power. But now when you input 3 like this, now this is a power. What is the meaning of this 3? You have multiplied this term by itself 3 times. Now see the position where I have written 2 and 3. There's a clear difference. When you write a number on the top of d here and on the top of the independent variable here, that is the number of derivatives you have taken. But when you write it like this, that's the degree. Now order means you are dealing with the number of derivatives. It has nothing to do with the degree. So it has nothing to do with this 3. So what is the maximum derivative you have taken here? 2, right? You differentiated the function twice, but you multiplied 3 times by itself. That's none of our business. We only care about the derivatives. So here the maximum derivative you have taken is 2. So it's an order 2 differential equation. Okay. All right. So let's take another example. So here we have written the differential equation in derivative form. So prime means the number of times you have taken the derivative, right? Here it's 1 in this term. Here it's 2. Now here it's 1. So you can see 3 primes. So that's 3 derivatives. But it's been squared, right? That's a power. That 2 is a power. You multiply y triple prime by itself like this. But it has nothing to do with the derivatives. We have only taken 3 derivatives here. So the order is 3. Okay. We do not count the degree into the order. It has nothing to do with the order. Okay, order is purely what is the maximum time you have taken derivatives in your differential equation. Okay, all right then, thank you very much.